Good afternoon. Good afternoon. I'm David Wilco. It's my pleasure to welcome you to this afternoon's C-PREE seminar with Rebecca Shaw. Rebecca is the Chief Scientist and Senior Vice President at the World Wildlife Fund. And in that capacity, she works with scientists and conservation practitioners from around the world to identify the key strategic questions related to World Wildlife Fund's mission and to marshal the staff and the resources needed to address them. Rebecca joined the World Wildlife Fund a couple of years ago after having served as senior scientist in the Land, Water, and Wildlife Program of the Environmental Defense Fund. And before that, she was the Director of Conservation Science and the Associate State Director for the Nature Conservancy's California office. So Rebecca has an extraordinarily wide range of leadership positions at conservation organizations that really span the spectrum of work from both the state to the national, international level, and has that rare combination of being both a conservation researcher and a conservation practitioner, which is one of the reasons I was so keen to bring her here to speak with us this afternoon. Also, if I may add, for the graduate students, postdocs, and faculty in the audience, Rebecca does have a little bit of time later this afternoon for one-on-one meetings. If you're interested, please get in touch with Chuck Crosby, gentleman over there, immediately after the talk. With that, let me welcome Rebecca Shaw.
Thank you. Thank you so much, David, for the invitation to come and speak to you all. I've been having just an amazingly fun conversation since I've stepped on campus, and I'm hoping for even more fun conversations in the afternoon. And I'm also even hoping that this is a fun conversation. So while I'll be talking to you about my work at the World Wildlife Fund, I do want to let you know that I do these kinds of talks because I'm really, really seeking input from experts about on the challenges that we face in the World Wildlife Fund, knowing that I could never address these problems and challenges alone, and neither can my staff. We can't even hire enough people, particularly as we move into a world that's faster paced and where the questions really need to draw on a vast number of disciplines in order to, that are actually interconnected in a way to really get to solutions. So I want to tell you a little bit about me so you understand my position. I'm the chief scientist for the World Wildlife Fund. The network is really big. Let me see. I'm doing things wrong. Excuse me, I'm going to get this right here. Oops. Can I go back? Is it possible? It's this thing. This is my computer.
I have no idea how to use that.
I'm sorry.
You can probably just do it from here.
No, it's not functioning.
No, my computer's not.
Oh.
I just need to go back to the beginning.
This is the back button here,
Okay,
the
perfect.
little one.
Thank you.
Okay.
All right, now we're ready. I have both a policy degree. So I went I did a policy degree at the University of California, Berkeley on climate policy before I did my PhD, trying to understand the impacts of climate change on biodiversity and ecosystem function. So big geochemical cycles and how that manifests itself in impacts on biodiversity and ecosystem types. I then went on to Stanford to do a postdoc where I looked at interacting global changes on ecosystem function and biodiversity composition, and did modeling while I was there. And then have since been in this world of connecting biodiversity and climate change together, and now some development. So it's really, for me, it's in my world of challenges is iterating back and forth between where the science is, where the policy needs to go, the questions you need to ask the science to deliver on where the policy needs to go, and iterating constantly. And what I want to talk to you about today is that years and years and years of doing this with lots of colleagues, we're at this crossroads coming up in the year 2020. And people often talk about the crossroads for the climate. We know we have to do something immediately to address the greenhouse gas emissions globally. But I also want to make the case that we're at a crossroads for nature as well. As we've seen the acceleration of both the wealth of nations, we're also seeing the acceleration of the impacts on the environment in ways that we never would have imagined. And these issues that we used to see, or these disciplines that we used to see as very separate, the climate, the work on biodiversity, the work on development, come together in ways that are highly interacted and need a new kind of science in order to take us into the next century. So we are at a turning point, not just in climate, but in the way we think about and develop knowledge to deliver solutions for the future in this fast-paced environment. So with that, you all know that this is a panda. Mostly I show you this not to show you that we work on wildlife. At WWF, we absolutely work on wildlife, but it's a big, important piece of what we do, but it's not all we do for sure. Our mission is very broad-based. It's to stop the degradation of the planet's natural environment and to build a future in which humans live in harmony with nature by conserving the world's biological diversity and ensuring, and this is a test, if anybody can read that, you get a meeting with me right after this. Well, I'll buy you a beer. No. All right, I'm buying you a beer. And so that's a pretty grandiose mission. To deliver on that mission, we work in 100 different countries around the world. WWF is structured differently than other NGOs are in that we are registered as, in a lot of the places, most of the places where we work, we're registered nationally as an NGO, so recognized as nationally as NGO, which is different than being US NGO that has work in those countries. You have certain rights and priorities given to you because you live in them. So we should be able then to deliver on our shared goals. And if you thought that mission statement was grandiose, look at these goals. By 2030, we have 7 global outcomes. And by 2030, we want to protect and restore 30% of land and sea. So that's pretty big. We want to eliminate illegal wildlife trade and reduce exploitation. We want to halt deforestation and degradation, double sustainable fisheries, sustain river flows and river quality, cut greenhouse gas emissions by 40%, and have the impacts of food systems. And if you're asking yourself, how does an organization of 7,000 people in 100 countries worldwide going to do something like this, it's a really good question. It's a really good question. Of course, we don't do our work by ourselves. We do it with partners. But I think the more important thing to recognize is that more and more as we move forward in NGOs, our goals become more of what has to happen, not what we can make happen. So we're in this again at this crossroads where these things have to happen for the functioning, not just the functioning of nature, not just for the functioning of the wildlife populations, but for the functioning of the human race. And so we begin to have more and more grandiose visions, and it strains the science to go to scale. So because we have these grandiose goals and missions, we have dashboards to track all our activity to see how we're doing. So we have our conservation dashboards. Each one of these colors is a different programmatic unit, and we track the progress of WWF's most significant initiatives towards our global 2030 outcomes in the context of key global trends. And I would say that, so we're always knowing what the context indicators are, how those are changing on the planet, our global outcomes, how we're doing towards those outcomes, and then how we're doing in our initiatives going to those outcomes. So we're trying as best as we can to systematically track. But you can imagine when you have those grandiose outcomes and you have only 7,000 people in 100 countries, and we're talking about systemic change in a lot of these places, it's a big deal. And we're not doing very well. Just to point out, we're not doing very well, not just as WWF, but as a community. We're not doing what we said we will. WWF puts out a report every 2 years called the Living Planet Report. The last report was in October 2018 that has an index called the Living Planet Index, which measures the health of populations of vertebrates across a number of continents. So this is population health, not species health. And what we see are declines in both the terrestrial and the freshwater, a 60% decline in the terrestrial Living Planet Index since the beginning, since the reference year of 1970. So big grandiose visions, big negative impacts. And if you put this in the context of the Convention on Biological Diversity, we knew that we had a problem 30 years ago, almost 30 years ago, with the Rio Convention. And so that's in 1992, we had the first Convention on Biological Diversity and the other Rio Conventions, and we set out big targets to develop national strategies and plans and programs for conservation and sustainable use of biological diversity. 10 years later, we got together at COP6 and we said, achieve by 2010 a significant reduction in the current rate of biodiversity loss. And then 10 years later, with more decline, we got together and we said, okay, let's get really serious this time. And this time we're going to have a strategic plan, 20 biodiversity targets across 5 strategic goals. And still, though we're headed to 2020 when we negotiate this again, and still it's a decline. And this decline is real, and it's in the context of a lot of other things that are good for humanity. So it's not all a bad story. We have we have economic growth on the planet, we have human health on the planet across multiple indicators like we've never seen before. But we're still at this crossroads. I think about the other things that in that context of the loss of biodiversity. We have a changing climate, and if you look at where we are just under 2 decades into the 21st century, and we are 2/3 of the way to our 1.5 degree target. So in the Paris Agreement, we set a 1.5 degree target. We're 2/3 of the way there. But already today, according to the IPCC 1.5 report that came out in October 2018, there are already people across the planet that are feeling the effects of the 1.5 degree target. And so this graph here then shows you warming relative to pre-industrial and the most strongly warmed seasons, the billions of people already experiencing 1.5 to 2 degree change, 2 to 2.5 degree change, 2.5 to 3 degree change. And so the impacts, this global mean temperature and its impacts on people are significant, and its impacts on biodiversity are even more significant. And so it's clear that we are really moving outside of a very stable climate that in which human civilization developed in the Holocene. We are moving outside of that very tight plus and minus 1 degree C frame with big implications. So not only are we moving way outside that, we're moving outside that faster than we ever had before. And I had to show this because this, for me, is one of the most fascinating findings in climate science in the last year. And it's by a geoscientist here at Princeton University that used these Argo floats to measure temperature and salinity at multiple depths. And the results they found were that not only are we changing, are we really 2/3 of the way towards our 1.5 degree target, but we're getting there even faster than we ever thought. And the oceans have retained 67% more heat each year than we previously thought. It was a really big finding. The bottom line is the trend in biodiversity going down, the trend in climate change going wrong, and the impacts of biodiversity of this climate change are very significant. We've had severe coral bleaching reported in all these areas circled in 2016, and as of 2019, 50% of all the coral reefs on the planet have experienced some level of bleaching, with many of them not returning to a prior state, or won't for many years. The other thing we're really beginning to think about when we think about climate change is the climate change and extreme events. There was an NAS report that came out in 2016 that looked at the attribution of extreme weather events in the context of climate change, and we're getting better and better every year at actually attributing certain types of extreme events to climate change. So we're with the effect of climate change high, the attribution to specific climate outcomes for extreme heat and cold, for droughts, extreme rainfall, and even for wildfires has moved up here, and extreme snow and ice. So we're understanding that not only are we 2/3 of the way to the 1.5 degree, we're experiencing more and more extreme events that actually can be attributable to a changing climate and increases in greenhouse gas emissions, with the strongest evidence to date from heat waves, coastal flooding, precipitation events, and severe droughts. And one of the things that we haven't thought about, and this takes me back to the biodiversity changes and the loss of biodiversity, is the ways in which this incremental change, the 2/3 of the way to 1.5, are interacting with these increasing frequency and magnitude of extreme events, these punctuated events, and how they're changing the environment. One example I'd like to use to describe this, because I think that people don't automatically attribute this to climate change, although it has been attributed to climate change, is the interaction between the lodgepole pine in Western North America, the temperature change throughout the West, the mountain pine beetle expansion as the minimum cold temperature increases in the winter, and the jack pine and the drought and fire. And what we've seen, I've taken these photographs or these images from the National Geographic's website, because I just think it's one of the best storytelling websites for things like this. That the combination of the slow, the incremental rise in temperature, the increase in the drought, the pest and fire. We've seen expansion of the mountain pine beetle across the range of North America. And as a result, big changes in the percentage of the trees we've seen damage, and a huge increase in the number of dead trees, and then massive wildfires as a result. All of these things attributable to climate change. The temperature increases attributed to climate change. The droughts attributable to climate change. The fires related to the droughts and the fuel loads attributable to climate change. And so 16 of California's largest wildfires have burned in the history of taking data on this thing, have burned in the since the year 2000. So 16 have burned of the largest wildfires in California in the last 18 years. And so this is the point I want to make here as we focus on protected areas for biodiversity protection. As we look at that loss in biodiversity in the Living Planet Index, we often don't think about climate change as impacting that loss, and we absolutely don't think about systems transformations like the scale that are happening in systems like this and its relations to climate change. So we look at the climate system and the biodiversity system as very separate. So I definitely want to go back to this graph just to say we are moving, just like the folks that talk about planetary boundaries talk about, we are moving outside of the very the very stable envelope that we have seen in the Holocene and into the Anthropocene. As you all know, 50% of the terrestrial ecosystems have been converted to food production, either cropland or pasture land. Again, 75% of the built infrastructure that will be in place in 2050 has yet to be built. I mean, think about that. Think about the number of roads, the bridges, the ports, the cell lines that will be built to support an ever accelerating and growing human population. What will that do to the biodiversity? What will that do to the climate? How do these two things interact? And of course, there's associated forest cover loss that's being documented across the globe as a result, primarily in the tropics. And the overharvesting across the planet, not just in the oceans, as this graph suggests, but also in terrestrial waters, in the terrestrial lands and in freshwater. All the socioeconomic trends are going up. So this growth has come, and this increase in the rate of climate change, this increase in biodiversity loss comes at an increase in human health and well-being. But it can't be the case that that can continue as the Earth system trends continue to degrade as well. And the conversation around planetary boundaries, that we're actually reaching planetary boundaries, is a very real conversation at a global scale right now as we talk about not just how do each of these boundaries, what should these boundaries be, what is the point of no return for each of the boundaries, the land use system change, ocean acidification, atmospheric aerosols, and so on. But how do these interact in a way, and how do we need to be thinking fundamentally differently about how we implement policies, how we interact across these relevant boundaries to achieve sustainability over time? And recognize that humans, the dominant influence on the planet and the ecological and atmospheric systems have been changed or outside the bounds of the conditions that allow humans to thrive. And our institutions at this point aren't well suited to take on this challenge. And I think this is one of the reasons why I want to talk to you, and one of the reasons why I'm really struggling with the work we're doing. The policy response on the biodiversity side, as we move to 2020 with the renegotiation of the Convention for the targets on the Convention on Biological Diversity, have been more protected areas. And granted, they're more bigger and connected protected areas, but it's more protected areas. So for a convention that is actually focused on protecting both the biodiversity and the services that are conferred by that biodiversity that underpin human health and well-being, to only be talking about protected areas first and foremost, I think isn't going to get us to where we need to be. Particularly in the context of what Convention on Biological Diversity has been able to achieve to date in the last 10 years. We saw the graph earlier on, and the Aichi targets from 2010 or 2012 to 2020. There were a whole range of targets that were state targets, driver targets, enabling condition targets, lots of targets. The state targets set out 17% of terrestrial, we should protect 70% of terrestrial biosphere and 6% of the marine habitat in protected areas. But we had highly mixed progress, with greater progress on the policy actions and very little progress on the state outcomes, so the protected areas. So we're actually calling now in many of our community are calling for 30% protected areas by 2030 when we haven't achieved 17% or 6%. And haven't really, with the same institution doing the same kind of work. In fact, there's many even saying we should just call for an extension of the Aichi targets, which are the targets that were set in 2010. Let's just say we're going to do 17% and 6%. And I would say in that context, what is that going to get us? Are those trends really going to change? What is going to change that could ever allow us to hit 30% by 2030, what realistically could change? And if it did change and we hit 2030, what is that the outcome we really need for a sustainable planet? Is that what we need from the Convention on Biological Diversity? And I do think we really need to think about, as we lose more and more biodiversity, what it means in the land system and what that transition means for our overall sustainability, and what that path might be, and what our institutions and how our institutions need to be different moving forward to deliver a different outcome. And so I'm shamelessly just ripping off this ad campaign from Apple from 1997, where we just really need to think different about the planet. We really need to think in a way that begins to connect what we're trying to achieve in sustainable development with what we're trying to achieve in the climate, with what we're trying to achieve in biodiversity, and see them as interconnected and connected to other sectors in ways we haven't before. An integrated solution then would have governments, the private sector, and the public understanding priority outcomes delivered through conservation of nature that are essential to human health and well-being, essential to clean air, essential to clean water, essential to a stable climate, healthy, abundant food supply, and wildlife abundance, not just biodiversity and protected area alone. So an integrated solution, so this is a symbol for the Sustainable Development Goals, the Paris Climate Agreement, and the Convention on Biological Diversity. An integrated solution would also include the private sector, not just the government sector, coming in and actually being able, when they make commitments, actually have those commitments deliver on the outcomes we seek. So the Sustainable Development Goals, which were designed for the first time ever in the history of development goals to have environment goals underpinning them, we actually truly make an effort now, moving into 2020, to identify the lands and waters for ecosystem services or the benefits to people that support human health and well-being. Those discussions aren't happening right now. They're not happening. The Aichi targets were placed there to underpin the Sustainable Development Goals, yet they don't really serve that purpose yet without a lot of work. We need to do more work on that. We should also be thinking about maximizing ecosystem-based climate mitigation, meaning in the Paris Agreement, where we have the nationally determined contributions, more of those should be focused on carbon sequestration, maintaining carbon in ecosystems, not just the tropical forest, but in the soils and other ecosystems as well. And then finally, we should have very clear biodiversity targets that connect to the environmental goals or nature's goals in those other conventions. So if we were going to go forward in the CBD with 30 by 30, what would we then be asking the Paris Agreement to deliver on nature and the Sustainable Development Goals to be delivering? We absolutely have to hit 1.5, and I'll talk a little bit about some research we've been doing on that. And then in this wedding cake graph for the Sustainable Development Goals, where it has at the bottom of it the environment underpinning those Sustainable Development Goals, we really do need to make that 50% of the planet that's under cultivation, either in crop or pasture land, work much more effectively, produce more food, more efficiently, and more sustainably than it ever has been. So I could accept a 30 by 30 goal for the Convention on Biological Diversity, as long as it has other goals and other targets that systematically are asking of the Paris Agreement and of the SDGs, and delivering for the SDGs as well. I want to point out that the IPCC report that there's the science for a lot of these conventions is very siloed, and we need to be bringing it together in a much more systematic way to understand how we might deliver on an integrated approach. The IPCC 1.5 report was an attempt by the Intergovernmental Panel on Climate Change to figure out how do we get to a 1.5 degree planet. And almost every single one of the scenarios in that report has an overshoot. And that overshoot, if you're a climate scientist, is not that meaningful, because by the end of the century, you're going to get to 1.5. So if you hit your target at 1.5, that's good. All of the scenarios have near-term global emissions, rapid, deep decline in global emissions. That's great. That's exactly what we need, and achieve negative emissions around mid-century. But all of them have an overshoot. And I want to talk about that overshoot in the context of biodiversity ecosystem functioning, because we've seen just what 1 degree of climate change does to ecosystems, how it disrupts it. I gave one example earlier on, but there's many, many others globally you could draw upon. And the shape and the configuration of that overshoot matters tremendously for everything we care about in nature and nature's benefits for people. It matters how big it is, the severity of the overshoot, its duration, and its rate of change all matter for what the outcomes we see in ecosystems and the potential for ecosystem transformations. But none of that has been looked at or delved in any systematic kind of way. We tried as just a cursory approach to try and understand what this would mean for terrestrial systems and the oceans by taking the burning embers from the climate change, from the IPCC report, and asking ourselves where they assess risk in terms of color. There's high risk in the red, lower risk of transformation in the yellow, and then we just place these scenarios onto a graph to understand if we have a below 1.5 degree target versus an overshoot to 2 degrees, what does that mean for the things and the things we care about and the goals we're trying to achieve? And for many of the things we're trying to achieve, so this graph shows you on the y-axis average years in each risk profile by each category, the Arctic, coastal flooding, crop yields, and so on, by each of these overshoot scenarios. So below 1.5, 1.5, at 1.5, low 2 degrees, high 2 degrees. And you can see the risk profiles to these different systems we care about really changes. And the length of time the systems stay in that risk, in that risk scenario, really changes as well. So it matters mostly for what this is telling you, it matters for the Arctic, for coastal flooding, of course for terrestrial ecosystems, for warm water corals and fisheries, whether we hit 1.5, whether we have an overshoot, how high that overshoot is, and how long that overshoot is. And this is a way that biodiversity ecosystem function is interacting in a way we're not really exploring in the climate change literature that we need to explore more. This would say, we need more data on this for sure. But one of the things we should be asking ourselves is, can we even go to past 1.5? Should we even be thinking about overshoot? And if we can't be thinking about an overshoot given the impacts that we'll see on the planet, what does that mean for our climate scenarios? We should be probing our climate convention, our climate agreement, in the same way we're probing this biodiversity. So this is just to say again that we have a current rate of warming. We need deep and fast cuts in greenhouse gas emissions to even stay under 2, but that overshoot is going to be very significant. So impacts of the overshoot, temperature extremes increase. I pretty much went over this in the last one. And this is just to say, if we want to maintain coral reefs, which is sort of the canary in the coal mine for all of us, we have to have deep, fast, and permanent cuts in greenhouse gas emissions. And so every time we ask ourselves what kind of greenhouse gas emissions we want, we should just deep, fast, and permanent. And this takes me to another part of how we're probing how these conventions and how these goals and these conventions are interacting with one another. There's a lot of talk right now in our community about using nature as a carbon dioxide removal mechanism, because it actually does remove carbon from the atmosphere. It's just whether it stores it systematically and does it fast enough for what we need. There's a campaign called Nature for Climate right now, and from this paper, Griscom et al., 2017 PNAS, they make the claim that at $100 a ton, natural climate solutions, which is the protection of carbon stocks in the biosphere or the enhancement of carbon sinks in the biosphere, natural climate solutions can provide 37% of cost-effective CO2 mitigation needed through 2030 for a 66% chance of holding warming below 2 degrees. So our community was just so excited about this because 37%, so nature can be 37% of the solution to climate, and you can get protected areas, and you can deliver enhanced and healthy benefits. One problem was the study was really nice in the way it laid out all the ways, all the mechanisms for climate mitigation and the costs. The one problem is, though, they only used one scenario, and that one scenario held greenhouse gas emissions from the fossil fuels steady. And the implications of doing that, we wrote up in a paper called Natural Climate Solutions Aren't Enough. In this delicate dance, we want more natural climate solutions, but we don't want to overclaim what they can do. And the issues to really consider and think when you're thinking back and forth between the conservation of nature and what we're trying to do on climate is that the burden of the 10-year delay in fossil fuel emissions creates more emissions than the negative, more than offsets the negative emissions you get from you implementing natural climate solutions. So that at the end of the century, if you follow their scenario, you end up blowing the end of the century carbon budget. We have a carbon budget of 600 to 800 by the end of the century. It increases or blows by that budget by 50% or 30% or 50%. So we're in a time right now when none of these systems act alone. When we're thinking about when we're thinking about climate solutions, we need to really keep in mind exactly what we need to deliver on climate and how it interacts with the conservation priorities, and the same on biodiversity, how the biodiversity and conservation priorities interact with climate. The last thing I'll say is I can't stress how important it is that we really get on top as a community what the scientific underpinnings of the environmental underpinnings for delivering the sustainable development goals will be. The Aichi targets actually are what, from the Convention on Biological Diversity, are actually what underpin the SDGs. I think we as a community know that there are ways in which the benefits from intact natural lands confer to humans and in ways they don't confer to humans. And we need to bring more of that very rigorous science to bear in setting indicators for the sustainable development goals. And the reason why I say this, currently right now, we're in want of measurable indicators for the SDGs, environment goals, and right now they're unimplementable. But if implemented and implemented well, you could imagine how we could have an integrated solution for nature conservation that delivers on biodiversity and delivers on protected areas at 30% and all the benefits that come from that, delivers on a 1.5 degree planet, but also makes and enhances that 50% of the land that's under cultivation much more efficient so that we don't have to expand the footprint for food production in the future even as population increases. There are huge science questions embedded in this. I've only begun to just dip into a couple of them, but I do want to challenge you to start really thinking about how these integrated bits come together. And one of the ways a group, WWF and EASA, has begun to do this is to really probe the integrated assessment models to use, if you take the original 2000 Saclo-Pacala paper about wedges and climate change wedges, where can you actually get the most impact for biodiversity? What are those wedges? And the integrated assessment modeling that they did came up with this really, really interesting, totally intuitive, and you would have said it anyway, but at least there's a model that says it now, that you can work if you want to enhance biodiversity. So this is a biodiversity metric on the y-axis. You can work through conservation alone, protected areas, so that's conservation. This is doing conservation only. to bend the curve and bend the curve on biodiversity loss and turn it back up towards restoration. You can work on demand side efforts, which means trying to keep people from either converting the land or taking the things from the land or the waters that reduce biodiversity. And you bend the curve much less, and you don't have recovery. Or you can work on supply side. What the integrated assessment model shows you is that if you combine all these in a really concerted attempt to deliver on the metric, whatever your metric is, that's this yellow line, you actually can bend the curve on biodiversity loss much more quickly and have recovery much faster. And so these are the kinds of, we always talk about something besides protected areas, but this is the first modeling experiment I know that says, if you want to deliver on biodiversity protection, you really need to go way outside your box, outside protected areas, and move on to both demand side and supply side interventions, and do that in a systematic way that's very intentional. So what's going to get us through this conservation's transition and through this bottleneck? I do think that the only way to keep that decline from continuing into the future for our setting ourselves targets, for Aichi targets in 2020 that end up with a decline in 2030, is that we look at our environmental goals in a very integrated way, and we begin to deliver on them across government, private sector, and civil society organizations in a way that's much more synergistic and contributive of one another than it has been in the past. And that will be the way we can actually achieve this mission and actually hit those goals. And I would say, my thought is, it will be the only way we will be able to hit those ambitious goals by 2030. And that's.
Thank you so much, Rebecca. We will take questions. I want to correct something I said earlier. I don't know whether I included undergraduates, or of course, welcome to schedule an appointment with Rebecca in the afternoon, particularly if they want to talk about the possibilities of careers in conservation and what that might entail. With that, let's turn to questions. Questions for our speaker. Do you want to take the questions?
Yeah, sure. Yeah.
Hi. How do you stay motivated to do your work?
I'm totally optimistic. So I would just tell you I wasn't. When I did climate for a long time, I spent a ton of time trying to help everybody in the late 90s, early 2000s understand how bad it was. And I get lecture after lecture about how bad, and kind of like this lecture. Oh, this lecture has hope at the end of it. My lectures earlier didn't have any hope at them. But the thing is, the thing that makes my job so fun, and being a scientist in an organization like it, is that science is about continually exploring, asking more and more questions, more and more. Like if I was a practitioner in my organization, maybe I'd be really depressed. But as a scientist, you can imagine and ask questions in a way that can deliver different outcomes. And that's what's incredibly important. And it's only a matter of time before we come to the solutions that can be implemented that will be more impactful than we are today. But I think as a scientist, being able to probe what's working, what's not working, asking the really hard questions, and then even when they're unpopular, to explore what a different outcome might be is just really fun. And the potential outcomes are big. And so it's that, oh, well, the potential outcomes are big. The probability that you're actually going to hit an outcome, really small, but it's part of that same inquiry.
You touched very briefly on chemical pollution, water quality as part of the integrated solution. I wonder if you could say a little bit more about the challenges from expanding efficiency of agriculture and from general manufacturing around the world.
Yeah, you got to know that this is not my area of expertise. And one of the things I do talk about, though, is our ability to, our need to think outside the box in terms of the kind of solutions that we can deliver for increasing efficiency of food production, whether it's food production on the land or in the waters or in the lab or something else. we need to be able to think about what the range of wedges might be that access to increase nutrition production for humans on the planet, right? And I think that is, I work in the environmental space, but I think the question you're asking runs across so many other sectors, including and disciplines, including ethics, ethics and sociology, that I would say this is one of those areas we have to dig in deep and really ask different questions than we have asked before, and really deploy disciplines and sectors we haven't deployed in the conversation. I wonder what your thoughts are about that.
Well, there's such a large number of chemicals that are very pervasive that we know interfere with reproduction in many species, especially aquatic species. Half of all pesticides interfere with biological reproduction in many aquatic species.
Yeah.
So that, I don't have the solution, but that's the challenge.
Rebecca, let me ask a follow-up to Joan's question, which is getting that 50 by 30 target. 50 by 30 says we got to up the efficiency of existing agricultural activities, because that basically gives you the ability to prevent more natural areas from being converted to agriculture. But at the same time, you're embedding that in an overall sustainability goal, which means you have to wonder how you can increase efficiencies without contributing nutrient pollution, pesticides, that sort of thing into the environment. And I'm curious, is that something that World Wildlife Fund is working on, and if World Wildlife Fund isn't, is academia doing that, or is it still largely in the domain of the crop scientists who have a very myopic view of what their mission is, and the pesticide industry?
Okay, so I think that last thing you just said is so important, because you just identified the way we've worked on these questions in the past and how broken those are. So WWF is broken like all in different ways, like all our institutions are, but we need to do things differently. So WWF's food program is moving from a program that largely was about getting the biggest companies to do more sustainable things in their supply chains for outcomes in lands and waters, through voluntary commitments and through certification. Well, we found out through 20 years of doing this that really you can put certification programs in place, but they kind of max out around 20%, and it's probably the 20% you would have gotten anyway. So while there's an amazing amount of stuff that happens with that 20%, best practices get determined and tested across the landscape, and you actually, in the seascapes, and you really, you fine tune what you need to do for sustainability. How do you get the other 80%? And how do you get the bottom 40% that are creating 80% of the damage? This is a really hard thing. So WWF's food program is moving now towards much more, what are the mechanisms for, what's the research we need to do to understand what this intensification needs to look like so that it doesn't create more unintended consequences, or consequences that are unintended but we absolutely know ahead of time. And also looking at how do you do that through very different vehicles than we have before. What should our protein intake look like? What kinds of protein alternatives could there be to hit nutritional requirements? So we have a really nice relationship, a conversation going on with the Rockefeller Foundation, where we're bringing to the environment side, they're bringing the human development side, to try and answer some of these questions in a way that can leapfrog towards new solutions without the same old problems of the old solutions. But this is a conversation that's just begun. Do you want to?
Please continue asking.
Please.
So my question is, I want to go back to your point about sort of the planetary boundaries argument, and from my very, very outside perspective, so I'm curious to hear what you guys would see from WWF perspective, that, this is proved a very sort of powerful analogy, and sort of biostability is sort of implied as sort of very ominous. But I guess the question was, to what extent do you see the kind of science being done in this area that is actually providing an estimate, a quantitative estimate of what those boundaries are that would be useful to a group like yours? Is that something that's happening, or is that something that that's sort of in the future, or where do you see?
So there's work that we're doing on the sustainable SBTN, sustainable science-based targets for nature. That is a very corporate focused. How do you set these targets for all these nature outcomes? The problem is it's not how the private sector interacts with the natural world. They don't interact with, now here's your fresh water, now here's your biodiversity, now here's, we're trying to come up with what those boundary targets are globally and what they should be in particular regions. But that is data intensive, and we don't have the data for that kind of thing. But I'll tell you, the planetary boundaries I find problematic for many of but I find it captivating as an entree point into understanding there are limits, and those limits express themselves either at the global, regional, or local scale, and we should know them. And so what science-based targets for nature then try to do is try to operationalize those limits from this very broad conceptual framework. It is so tough, and it's so tough. It's not working, but I think the aspiration is right, and I think that as a conceptual idea that there are limits and we should operate within them at multiple scales, I think is a really important idea. Yeah.
I mean, I totally agree with you about this nature-based solutions as wedges for the climate problem. But how dependent is that on having a carbon market? And how are you going to get the energy for having a carbon market going?
Okay, so this is the big question. No, I mean, really, so this is the big question. I mean, when you say natural climate solutions, $100 a ton, the carbon's only selling at $10 a ton in the 2 or 3 places where there's actually a market, and that market is really limited. So without a price on carbon, how does any of this stuff happen? That is the big question. And I think that one of us, or all of us, are really asking ourselves, how many more massive disasters that are either direct or indirectly related to climate change do we need to have before we have a consensus enough to actually put in a carbon tax or have carbon markets? I don't know the answer to that, but I think it's an important behavior and sociological question, because there have been other things that have happened that seemed impossible, improbable in the past, that actually happened because you had enough big events with stories around them that actually shifted public opinion. I think we should be ready for those, and I think we should know what that would look like when it comes, and be ready with plans on the shelf.
You said that the Sustainable Development Goals are unimplementable, so I don't disagree with that. I'd be curious if you could elaborate a little more.
Okay, so I don't mean to be like across the board saying they're unimplementable, because I think we're doing a great job of just blanketing the planet with infrastructure. So that's happening like mad. So that infrastructure icon, those are totally implementable. It's got the financing, it's got private sector behind it, it's happening. What I was mostly saying is that it's the environmental underpinnings of the SDGs that are unimplementable, just like a lot of the CBD targets are unimplementable because they're one and the same. And the other thing is the CBD targets were never developed to deliver on human development. And so if that's what we want them to do in the future, they actually really need to be structured very differently. And I don't think as a community where we claim that nature has benefits that confer to people, and those benefits are real and they increase human health and well-being, we can't make that claim if we're not willing to reconfigure the Convention on Biological Diversity to truly underpin the human health and well-being long-term. So IPBES comes out with the Intergovernmental Panel on Biodiversity and Ecosystem Services comes out with its regional reports and its global reports in the first week in May in Paris. And we're looking to that to sort of set a direction and set the stage, because it's a government-approved report for all the signatories to the convention, we're looking for that to actually make a shift in the Convention on Biological Diversity, so we really start owning what nature delivers in terms of species diversity and habitat diversity, genetic diversity, which the Convention on Biological Diversity is really good at spelling out, but it also really gets much clearer about how it delivers on the benefits to people, and so the rest of us can get going on the science of delivering benefits to people through conservation of nature and so on. So that's why they are unimplementable now, because they weren't designed to deliver truly on the sustainable development yet. But I think we need to get there.
You use the term efficiency a number of times when you talk about cropland productivity, but you didn't mention GMO effect on productivity.
So this is where I take the microphone off.
Yeah. Did you do that because of the political pushback against GMO crops? Because that's had a tremendous impact on productivity, especially in the American production of corn and soybeans, et cetera, and probably could do the same for other food crops.
So I really looked to the National Academy of Science report that says on balance, there are some big gains in some areas with GMOs and some the benefits aren't as good as people purport them to be, and the downsides aren't as bad as people purport them to be. There's less variability in the outcomes and across the board. So I look at that study to say GMOs in a targeted way deliver some big outcomes, and we need to be that targeted in the future with fewer downstream unintended consequences. So one of the ways I've been, as a scientist, I've been looking into this more, is really looking at what's going on with genetic editing right now, where it's very precise. To see, is there a way you can probe, can you use genetic editing? And I'm using a different term than GMO, because I'm using the more precise genetic editing, which I know is problematic. But we were just having a conversation this morning about nitrogen fixation and the multiple enzymatic pathways for nitrogen fixation, and the degree to which we know or don't know how the different enzymatic pathways get triggered. And could you actually eliminate nitrogen pollution by understanding that better and using genetic editing with the right kind of input into an agricultural system? So I'm just way outside the bounds thinking, is this possible? I don't know, because this isn't my field of study, but I do think we can't say this. We don't want more nitrogen pollution. We know the horrendous impacts that has on biodiversity and on human health. So what is the alternative, and can we begin to explore these connections in a different way than we have in the past? So I don't have an answer, but this is why I come to places like Princeton, is to better begin to explore these with smarter questions.
Rebecca, thank you so much for a really interesting talk.